Let's get going. My name is Josh. A little bit about me, first and foremost. I'm a Christian, husband, and dog dad. There's my list of hobbies right there. If you want to chat about those with me later on, feel free to come up at the John Deere booth after this. Whatever you want to do, happy to talk about all that stuff. A bit about me from a professional perspective. I work for John Deere as an application security engineer. I also have experience with some software development and cloud development. I've used AWS for my entire career, and that includes a couple of certifications up there. A number of disclaimers real quick. One, I have used AWS my entire career, so if you use anything else like a Google Cloud or an Azure or something like that, that is A-okay, but just be warned, I might say some stuff that sounds a little bit different because it's specific to AWS. If you have any questions throughout this entire talk, feel free to just shout out, blast an air horn app on your phone, whatever you need to do. Just get my attention, let me know you want to chat about something. We can try and go in a little bit further detail. However, this is a Cloud Security 101 talk, so I'm going to be very, very high level. I was having a really hard time trying to blend this mix between giving y'all valuable, useful content and also keeping it high level, keeping us rolling. So just keep that in mind.
Do you play Farm Simulator?
Farm Simulator? No, I have never played Farm Simulator. I have done some stuff with Minecraft, which feels pretty similar. So, awesome. It's really ironic that I'm having a talk called Cloud Security because the theme for today is cloud is not security. And I want you all to keep that in the back of your mind throughout this entire thing. Cloud is not security, and we're going to talk a little bit more detail about that. Before I get too far into it though, I want to discuss the difference between on-prem infrastructure and cloud infrastructure. Now, why am I doing this? Why would I have a cloud security talk and talk about on-prem systems? The reason is because cloud is not security, and I really want to kind of distinguish the differences between an on-prem environment, come on in, all good, an on-prem environment and a cloud environment, and what the advantages and disadvantages are of both, and you'll note that something is missing. Okay. So first and foremost, I like to do this all with the metaphor of trucks and trains. I think it's a pretty good comparison point. I think it helps kind of show off some of the critical differences. So if we think about a truck and a cloud computing environment, what are some of the advantages of that type of transportation, that type of data transformation, or transportation, there we go, if you will. So first couple of things you'll notice, cost and convenience. If you want to ship something anywhere, you can get a bunch of different size trucks. You can ship them to any location. It's pretty convenient, and there's lots of availability there. It's also relatively low cost, especially when you compare it to something like a train that is incredibly capital heavy. Additionally, in the cloud side of things, compute resources, very easily accessible. You can get all sorts of different kinds and you can spin them up and down as you will. Very convenient, very cost friendly. From the tooling perspective, if you think about trucks, you think about all the different types of trucks you can get. So there's probably a trucker in here somewhere that's gonna be so pissed at me. I'm sorry, y'all. Just a metaphor, stay with me, okay. Trucks, think about cement trucks, trucks that move big houses, trucks that move any kind of random thing. You slap a John Deere tractor on a truck and ship it across the country, right? Tooling, trucks have tons and tons of tooling. In the same way, cloud environments, they distinguish themselves, they kind of put themselves out into the marketplace with the tooling they provide. Finally, scalability. If you want to ship one thing, you get one truck. You want to ship 1,000 things, get 1,000 trucks. Same way, you want to compute one thing, you get a teeny tiny little computer in a cloud and you run it for fractions of cents. You want to compute 1 billion things, you can do that. You get a massive computer, a massive set of computers, and you're on your way. So, trucks and clouds. Now let's think about trains and on-prem environments. I'm just going to go through all of these in one chunk. The really big thing about an on-prem environment is it gives you these 3 benefits: control, visibility, and compliance. You know exactly what's there, you know exactly what it's doing, you can control every single detail, and you can comply with everything you need to. In the same way, when you're building a train track, when you're building a railroad, you're buying the land, you're buying the rail, and you're putting the track exactly where you want it to go. Additionally, if you think about trucks, they're scattered all over the place. They're off in the wind. They're hundreds of miles away from each other across all these different cities and everything. Think about a train's in one spot. even if it's in a mile long, even if it's huge, it's still just in that one location. And so when you see that, you know where it is. All right, let's talk some of the negatives with cloud and with on-prem with trucks and trains. All right, what are some of the problems with trucks? Well, you're on a shared infrastructure, you're on a public road. If the government doesn't fix the road, well, then your truck's not going to drive very far. In the same way, if AWS or another cloud platform has some troubles, or if if there's like bandwidth issues or whatever that is, you are restricted to that, and that's what you have to deal with. Additionally, there's a lack of visibility. AWS and the other cloud computing companies, they're private. They're going to have things behind the scenes that they're doing, and you just have to deal with that. The same way, you don't know exactly what's going on, even if the government tells you they're going to build a road there. Who knows when they're going to do it, how they're going to do it, that sort of stuff. Finally, this one is huge. This one's going to come up again later. Variable cost. When you are sending one truck out, it costs a certain amount. When you're sending 1,000 trucks out, that costs a very, very different amount. In the same way, when you talk about the scalability of cloud computing, there is tons of variability in the cost, and that can be a huge negative for companies that need to plan ahead. So, train perspective, on-prem environments. What are some of the problems here? Well, it's all kind of right here. Higher cost, higher maintenance, capital risk. That is huge for companies. It's so much money, so much time investment, so much risk investment to set up an on-prem server system that you really need to have a really, really good reason for it. Additionally, once you have it, it's hard to scale. In the same way you think about trains, you think about all of the land and rail you have to buy to put a train on it, and it's only going to go from point A to point B, right? Maybe, a couple of stops along the route. But if you want a train that goes off in the completely other direction, that's a whole lot more cost, capital investment, all that sort of stuff. So, we got that in our minds, this trucks, train, this on-prem cloud computing idea. What's missing? I already told you it. Security. Security's not here, y'all. Security is not really a benefit of an on-prem system or of a cloud system. Now, there are many, many nuances in that. So some of y'all might be getting a little mad at me about how easy it is to secure one versus to secure the other. But inherently, at the start, security is not something that is built in. You have to do it yourself. You have to get the resources, put those resources in place to make something secure, regardless of where it's hosted, whether that's on-prem or in the cloud. So back to point number one, cloud is not security. Awesome. So our first topic when it comes to actual cloud security and actually securing something, my favorite topic, I work as an application security engineer, application security. So let's head back to our trucks versus trains example. What happens if we take one of these big oil tankers back here on the train and we pop a hole in it, right? It starts leaking oil everywhere. What are we gonna do? Well, we're gonna get a crane, we're gonna go over to that tanker, we're gonna pick it up, and we're gonna put it on a truck. And we're good, right? None of you are laughing. I thought that would be funny.
Set on fire.
Obviously, that's not going to fix anything. In the same way, you can't just take a vulnerable application that is sitting on an on-prem server and lift it and shift it into the cloud environment and have it be secure. That doesn't work. That doesn't make any sense at all. But because cloud is so shiny and special, we think to ourselves, no, this is something we need to do. We need to move it in the cloud, and then it'll be safe and it'll be secure. Now, there's definitely some nuance to this, so we're going to play ourselves a little game. Do y'all know what command injection is? Raise your hand if you know what command injection is. Okay, there's a lot of y'all that don't, so we'll go over a very brief explanation. In a server sitting on whatever environment you choose, you might run some commands. You might have some code that runs. And if for some reason you allow a user to be able to submit their own commands, to be able to submit their own information, you could potentially have that user run commands on your server, which could be very, very, very bad because you can do some crazy dangerous or crazy exploitive things with commands on a server. So, really simple overview of command injection. Where do we think? Is command injection going to be worse in an on-premise environment or in a cloud environment? On-premise, anyone? All right, how about a cloud environment? A lot of people didn't raise their hands, so y'all think I'm tricking you? No, I'm totally serious. Command injection is in general, way worse in an on-prem environment. Now, why is this? If y'all remember back a number of slides, I talked about tooling in cloud environments. There's so many different tools, so many different approaches to computing in a cloud environment. Some of those are very distinct, very individual. Maybe there's some containerization or something that's going on. What that prevents is spread. It prevents command and control. When you have a command injection attack, there's so many things that an attacker can do once they're under the server, or once they're under the surface, once they're in the server, once they have a little bit of control, they can expand. But that only works if you provide them an opportunity to expand. In an on-prem environment, generally you have a lot of long-running servers that are all close together, so to speak, and it's a little bit easier to kind of move about a system, to take over control, and to kind of expand your empire under the surface a little bit. So that's command injection. We're going to talk about one more. How many of y'all know what server-side request forgery is? Okay, this one's rough. If you want to write it down and take a look, it can be pretty confusing at first. So I'm going to try and give you the really, really simple overview, and hopefully it'll be enough to at least get us through this section. So, server-side request forgery. Think about it like every server you have, regardless of where it is, needs to talk to other servers. There are other things that are happening across your environment, and you need to know about them for one reason or another, whether it's some business logic or some specific API call that needs to be made, whatever it might be. So, when you give user access to those requests, to those interactions between servers, they can forge their own request forgery. And they can forge that request to anything they want in your environment or outside of your environment. And using that, they can do malicious things. So just keep it in your mind, servers talking to other servers. So is this going to be worse in an on-premise environment, raise your hands, or a cloud computing environment? A lot of people do not know, and that is A-okay. I guess that's probably why you're here. Okay, this one is going to be so much worse in a cloud computing environment. And let me give you the reason. Google. If I found a server-side request forgery vulnerability in John Deere's system, in John Deere's service, I would have to spend days or weeks learning about the infrastructure, learning about the types of servers, the types of programs running on these servers, and trying a bunch of different, probably brute force or maybe slightly smarter methods of interacting with these servers in order to create request forgery type exploits. With cloud, everything is documented, and it's documented super clearly such that you can Google less than 20, 30 characters, whatever that is, and find a bunch of results for how to create a server-side request forgery payload and then immediately use it. So it's not just that you have this vulnerability, it's that everyone has the knowledge of how to exploit it incredibly quickly. So you picked up that leaking oil tanker and you said, no, it's going to be better in the cloud. And in fact, you just showed everyone where the leak was and how to light it on fire or whatever it might be. Now, why am I talking about, oh yeah.
So with server-side request forgery, since you're in a cloud environment, not only would that affect your multiple cloud computers, would it affect another company's cloud computers that's right beside yours in that small environment or in that server environment?
Likely, if you had a server-side request forgery vulnerability, it wouldn't affect other companies around you because AWS and other cloud computing companies, they have really, really good logical and physical controls in place to prevent you from accessing other company information. However, what it would probably let you do is more easily infect a larger cloud environment that you're in rather than just individual little snippets of the environment. Yeah. So why am I talking about server-side request forgery? It was really confusing to me when I first started. Clearly, y'all either haven't heard of it or it's something that is maybe a little bit less familiar to y'all. So why am I even talking about it if we're just going to brush right past it? Well, because in 2019, Capital One had a data breach. It affected more than 100 million people. It cost $80 million to the company just in penalties. I don't know how much else they spent on it. What was the problem? They had a server-side request forgery vulnerability, and AWS distanced itself from the responsibility of it because it fell into the bank's purview. Cloud is not security. And if you have this type of vulnerability, one that is easy to exploit in a cloud setting, and you just picked it up from an on-prem environment and moved it over, you just made yourself so much more vulnerable, and you could have incredible risk. And AWS, they're not gonna help you with that. They say you're on your own. Now they might give you resources ahead of time to maybe help avoid some of these problems, but once you're in the hot water, they're just gonna leave you there. So, how are we gonna remediate this? This is application security. These are not necessarily cloud-specific things, but these are things that we need to keep in mind. If y'all went to the talk yesterday, the application security talk, there was some really awesome stuff in that about training. But application security reviews, stuff that I do, secure code training, super important, just helping developers understand, what a secure code look like and how to prevent these types of vulnerabilities in our environments. Static analysis and dynamic analysis, security testing, that's what BSD stands for. So just different tools to help find vulnerabilities in your environment. These are all incredibly important in terms of application security. Additionally, we want to look at things like external penetration testing, bringing somebody else in to say, hey, you've got a vulnerability here. This is how easy it is to exploit because we're sitting in the cloud and there's documentation for it. And finally, just write less code. It's just that easy, right? If you don't put something out there because it's unnecessary or because it's extra on top of stuff that you already have, if you don't put it out there, it's not going to be vulnerable. It's really that simple.
Can
All right.
a WAF help?
What, sorry?
Can a WAF help?
Yes, it can. That is an amazing feature. That goes back to the tooling that AWS provides. But if you rely on that sort of thing and you say that's our security, it's not going to work.
It's kind of like SQL injection. A WAF can stop SQL injection, but why don't you just go back to the source?
Right. Yeah. Well, and it's only going to stop SQL injection so far as it knows that is SQL injection. So if you find a novel way to have SQL injection go past a WAF, or there was an article maybe a year ago about the size limit, that WAFs can only scan up to a certain size. So if you make a incredibly large payload, well, the WAF's just not even going to scan it. It's going to send it on its way. So next, once again, 100-mile high overview of architecture security. This could be a series of 10 talks. We could have an entire 2-day symposium on architecture security. So really, all I'm going to try and do is give you just a few simple things to keep in the back of your mind going forward. And we'll see what happens from there. How many of y'all have heard about the LastPass data breach? Okay, that's the most hands I've seen up so far. Fantastic. Yeah, it's horrible, right? Really, really bad stuff. I have LastPass, and I am not thrilled. Yeah. So, what happened? Why was LastPass breached? Well, there's tons of reasons, but one of them is backup security issues. One way or another, their backups weren't secured how I would have preferred they had been, and that caused them some issues. So, when we're thinking about cloud architecture and we're thinking about what kind of things that we need to secure in our environment from an architectural perspective, backups are key. Backups are a huge, huge component. There are entire sections of AWS certifications about backups. We need to keep in mind things like encryption. Just simple stuff. Are we checking the box encryption? Are we making sure that we have our permissions in place so that our backups are encrypted? We need to think about read and write access. For write access, the only thing that should be writing to a backup is the initial copy of the data. You have one database, that database should be the only thing allowed to write to a backup. There shouldn't be anything else. There's no reason that a developer needs to be modifying a backup and not the existing copy. If there is, come talk to me afterwards. Let's see what we can figure out there. Additionally, read access. This is, my guess would be that there was some kind of read access issue with a data backup, and that was how LastPass got vulnerable in this area. But read access should be incredibly minimal to a backup, because once again, the data should be in the original copy, right? So you should only be using a backup if there's some kind of emergency, some kind of extraordinary case for that information to be looked at. So that's just some of the stuff you need to think of if you're designing a backup. Like I said, this is super high overview, so we're just gonna keep cooking. Let me know if you have questions. All right, This is a little bit confusing if you've never seen cloud architecture before, so if you'll stick with me here, I want you to ignore everything on the page except these 4 words: public subnet and private subnet. At the end of the day, so much of a cloud computing environment comes down to what do you make public and what do you make private. So in this instance, we have a private subnet, and we've got our compute instance sitting in that private subnet. What that means is you don't have that instance by itself exposed to the outside world. You don't have attackers hitting that instance directly. They have to hit it indirectly, which can complicate all kinds of things if you're talking about an attack surface and you're talking about some variety of hack. Then in the public subnet, you see all this other stuff going on. You might have network control lists or routers or gateways, internet gateways, all this sorts of stuff. This kind of stuff is one area where cloud can become secure. Cloud might not be security, but implemented properly, you can really add a lot of great security to it. But you've got to know what should be private, what should be public, and then from there you have to know what do I put into a public or a private context to make it secure. I'll tell you a little bit more about that and just like how to do that in just a sec, but we'll talk about one more real fast here. Remember how I mentioned variable cost near the beginning of this talk, right? Variable cost, at least from a business perspective, is horrifying, right? You got to be able to budget. You got to know exactly what kind of costs you're going to have, and maybe you're within 5% on either side. That's okay. But what if you have a Lambda function? Lambda functions are these tiny, tiny little compute instances, cost cents at the most, maybe like $1 or $2. Like they should not be a large cost. What if you accidentally create something kind of like just a monster that's hidden under the surface and it explodes, and all of a sudden your couple cent Lambda function costs you thousands of dollars? That is horrifying from a business perspective, and from a security perspective, it's not great either. So what happened in this instance, this was just something I Googled and found online. A guy hooked up a small compute instance to every log message in his environment. And you think about just a standard cloud environment, lots of logs flowing through, lots of just random junk that you don't need unless you're looking for some specific little thing. So think hundreds of thousands of logs every minute, every hour. And if every single one of those logs triggers a small compute instance to run, even for just a couple of seconds, even for just a couple cents, a couple pennies, whatever it might be, that could still be a significant amount of money. So from an architectural perspective, what do we need to do? Not only do we need to understand how to secure what we're doing, but we need to make sure that as we're doing that, we understand what are our budget constraints, what are our business constraints, how are we going to make sure that this thing is effective moving forward for both the business, for the developers, and for the users, all that sorts of stuff. So I said I'd talk about how do we manage some of these things, how do we secure some of these things. Well, this is a 101 talk, so I'm basically just going to tell you to go learn more stuff. AWS Architect certifications, they're very helpful, or the Google Cloud or Azure, whatever equivalent. The key detail here is that you really want to learn how to learn these things. You want to learn that it exists somewhere and I can go learn it to then implement it properly. Additionally, AWS has something called a well-architected review. I'm sure there are equivalents throughout the industry. I think that they either do this for free or they kind of associate it with business contracts. But basically, they will go through your environment completely. They will help you make sure that everything is set up exactly how it should be to fit your business and your security needs. And this kind of stuff is super helpful because it takes cloud, which isn't secure, and it can kind of morph it into something that is. Finally, this is just across the board. If you are in a development space, you've got to have robust lower environment testing. If you don't have that, you're going to get to production, you're going to be surprised by something, and that something could be incredibly vulnerable and could lead to some kind of hack or data breach, or it could just cost you thousands of dollars in a week. Okay, I'm going to take a drink of water. What do you have for questions so far?
I assume you're setting up your own servers, developing your own applications in that scenario. Like where I'm from, Campbell University, we don't do that.
Right.
But we do have SaaS applications.
Sure.
We have to make sure that all those questions that you ask is part of our SLA, a service level agreement.
Absolutely.
And our contract. So I don't know if the rest just needed to know that, but just sharing.
Yeah. And that's a huge thing. It's kind of outside of the scope for this talk, but the whole idea of having a third party and trying to keep that third party secure or make sure that their security standards match yours or exceed yours, that's a huge headache to tackle, to deal with.
What about third-party supply chains?
Third-party supply chains are even worse than just one third-party supplier, and it's all just a bummer, and it's something that there's going to be a big transformation in the software industry in the next how many years. If y'all have heard of SBOM, software bill of materials, for y'all that don't know it, I heard about it for the first time maybe a year ago. People were going crazy about, oh, we need SBOM everywhere. It's a huge thing. It's going to be a huge shift in the industry in the next couple of decades to cataloging everything to make sure that from a third-party perspective, you know what is going into your code and what isn't in your code, hopefully the vulnerabilities. All right. Well, I've got a little secret to share with y'all. Generally, when you give a presentation, or at least how I was taught, you want to take the most important stuff and put it at the beginning and at the end, because you want people to, remember those things. The first thing that you come in and hear about, and the last thing that you leave with, that's the stuff that really sticks in your memory. Well, I'm breaking that rule, and I'm putting the most important thing next, because to me, not only is it most important, but it's also the easiest thing I'm going to talk about today. Now, it's a little bit of an oversimplification, but to me, this is just so easy. When you think about a cloud architecture or something like that, there's a ton of nuance, there's a ton of things to learn, and it's all very contextual, very individualized. This is pretty straightforward. Configuration security. How many of y'all have heard the term infrastructure as code? IAC. For y'all that don't know what that means, in a cloud computing environment, rather than just clicking through a console, clicking through a website, and setting up your computer infrastructure, you code it. You code out exactly the specifications of the thing you want, the type of compute instance, the type of operating system or other type of application running on it, the ports that are open, public versus private, very huge thing in terms of configuration. All of that is done with code. And that's very important because it's very helpful in terms of moving developers along quickly and in terms of having everything be consistent. But there's kind of an issue. If we think back to our trucks and trains example, what happens if we take something that's supposed to be really secure and maybe let's say it's really private, people aren't supposed to look at it, and we slap it on flatbread.
That's good too.
Oh, y'all, it's not even lunchtime yet. Okay, we slap that thing on a flatbed, take some tie downs, throw it on there, and we just send it off into the country, right? You're not supposed to see it, but there's no fancy walls around it. There's no covering over it. Or let's say that we do put a covering on it and it's a clear tarp. That just doesn't make any sense at all. Someone did not think about the fact that this thing needs to be kept from public view, and yet it's driving through the countryside, beautiful Iowan I-80 countryside, and everybody can see what it is as it drives along. This is how I think about some of the simplest mistakes that are made in configuration security. I had a really hard time with this talk doing research. I like to get a lot of examples of real world incidents, and every time I was Googling for a specific type of cloud security incident, 50 S3 bucket public incidents would come up. This is 3 of them. I'm confident you could find 10 in the rest of this talk. If you chose to ignore me, just go look for S3 bucket public. You'll find all sorts of stuff. American Voter PII in 2017, there was an S3 bucket that was open and a bunch of that PII got exposed. What is that, in South America? Yeah, a bunch of airports in South America had terabytes of information stolen. Sensitive information about airports as well as, I believe, customer information as well. And finally in Ghana, there were, I think it was their high school network had an open S3 bucket. And what is that number? 500,000 people had their PII exposed, because for all 3 of these examples, it was so simple. Someone didn't check a box. That's literally it. The difference between a public and a private S3 bucket is 1 click. It's 1 button press. And maybe it's slightly more complicated than that. Maybe you have to add some extra settings on the surface, whatever. It is so easy to take something that is instantly exposed, instantly accessible on the internet, instantly available for anyone in the world that wants to go look for it. Able to find it so easily, or click a couple buttons, change just a couple little details, and it is significantly more difficult to access that information. So the solution is simple, right? At least in my opinion it is. This is something where you really just need to make sure that your developers, the people working in your cloud environment, understand public versus private. In cloud, that is huge. It's so important that a developer knows, hey, when I make something, unless there is a strict business need, got to mark this as private. Additionally, as a company, whether it's small or large, just having some well-defined policies in place really can make a big difference here. I think that when you think about a tiny company, a little startup that's just beginning, generally you'll have just a few developers, and those developers hopefully are pretty good. They're very self-sufficient, if they're working for such a small company. Even then, it shouldn't be hard for them to kind of come together as a team, as a unit, and say, hey, we're not going to make this stuff public. We're not going to expose this unnecessarily. We're going to put all of this in a private subnet, whatever it might be. Or if you think about port security, computer ports, we're not going to allow port 21, port 22, anything over port 443, all those ports should be closed to the external internet. It's simple stuff like that. Finally, this is huge, especially as your company gets large enough and you can afford it in terms of tooling. Automated scanning, and sometimes even automated remediation. This stuff is very simple to find because it's so binary. Is port 22 open? Yes? Okay, should be closed. Is this bucket public? Yes? Okay, should be private. If you can automate going through and clicking the box for the developer and making it private, even better. But this is one of the few things that you talk about in cloud security that is so binary, so easy to just say yes or no, okay, it needs to be the other, or yes, it's secure, great, it's secure. I was told that I wasn't allowed to show logos from other companies because I work for Deere, and I guess that they get a little sketchy about that. So this is a list of companies I found on the internet that do this sort of stuff. Not an endorsement, just if this is something that's right at the top of your mind, or something that you want to look into deeper, any one of these companies should have some solution, and that can be very helpful. Okay, finally today we're going to talk about policy security. Now, once again, we're getting back into the land of nuance and uncertainty, and no one's going to do it perfect, but we can all strive to do it well. So what is policy security? Policy security is my way of talking about identity and access management. For those of y'all that haven't been in AWS, they literally just call it IAM. Once again, pretty hard to Google for stuff because IAM in AWS is the same thing as IAM out of AWS, and so trying to get a specific resource in or outside is a little tricky. But basically, every time you're a developer, every time a user wants to access a resource in AWS, whether that's some kind of compute, some kind of storage, some kind of whatever it might be that you can think of in a cloud environment, there's going to be a policy, there's going to be a role, there's going to be a security group perhaps, some piece of security implemented into the system that allows them to move forward or tells them, no, you can't do it. So we're going to talk just ever so briefly. There was a big attack against GoDaddy, and specifically what they were looking for is SSH credentials. I just was talking about IAM, why am I talking about SSH credentials? Doesn't really make a ton of sense. All right, here's what. Credentials are your ticket into the cloud computing world. When you are in an online environment, your digital identity is summed up or is consisted of some credential, some set of credentials that represents you to those computers. Rather than it being, an ID photo or whatever, it's just this long string of characters that says you are who you say you are and you have access to this or that. And this is a huge, huge target for attackers because any one of those credentials could have some type of extraordinary access beyond what they should, or access to a very specific set of PII that might be useful. So just generally, credential attacks are on the rise because that is gold to attackers. And it's something that we need to secure. So credentials and policies, really, it's both, right? You have these credentials, they're controlled by your policies, and you need to make sure that the policies you write are written well. So real quick, just for AWS, when you talk about a policy, you're talking about who, what they can access, what and can access. Yeah, I don't love how this slide is written in terms of talking it out, but those are kind of the different components. You need to know who they are. You need to define a specific access list. Sometimes it's it's an allow list. Sometimes it's a deny list, depending on which environment you're in, what type of security consideration. There's a lot of things now that are allow list only. It's a deny all by default, which is generally very useful. And finally, what? This is critical as well. Depending on the environment you're in, there might be very granular level controls. There might be very broad level controls, and understanding the differences there and how you can use a specific type of control for your specific resource, that's important. More than just like coding it or understanding like what it is, one thing that I wanted to talk through and kind of make clear is why this is the case and kind of what like the mindset is behind it. So rather than talking about trucks and trains, this time we're going to talk about tree rings and honeycombs. If you think about 30, 40 years ago, if there was some kind of access control, if there was some kind of authorization to a resource, it most likely looked like a tree ring. If you are a user, just a basic user, you have access to anything another basic user does. If you are an administrator, you have access to everything that an administrator does, all this core little functionality that nobody else should have access to. That's fine. It gets the job done, especially in some low security situations. However, what cloud companies are trying for today and what is better for the future is a honeycomb model. If you have one resource and you can access that resource, maybe you can access a resource right next to it, maybe you can kind of branch out a little bit, but you definitely can't get to something over there. There's no route to get all the way around. Rather, everything is segmented, everything is separated, and you have to give access piecemeal. You have to give access individually. Now, all of that works until you start adding in little asterisks, little wildcards that say, yes, you can access anything here, right? They allow that because it's very useful for developers, very useful to be able to access anything in a specific bucket, anything of a specific type of computing instance. But that gets really, really dangerous from a security perspective, because once you open the floodgates on this kind of thing, it's not like you can only go in one circle. You just kind of expand outwards into everything. So as we talk about policy security, this battle, this tension comes up between the access you need and making sure developers can get their job done. I was just talking with my wife yesterday. She's a developer, and she has access to, oh gosh, what was it? It was like she had access to the code, to the GitHub, and to their like planning board, their like Kanban board or whatever. But she didn't have the right access to the Kanban board to then create something in GitHub to then do some code. So it's like, she's got the whole like set of access, but like one thing she wants to do in the code, she doesn't have access all the way down the line, which is so frustrating as a developer. It's something that we deal with constantly, and you really don't like it, but from a security perspective, there's got to be a balance there, because we can't just give access to everything. We got to find the right little honeycomb for you to sit in where you can access the resources that you can without getting a whole swath of information that you don't need to. So how can we do this in maybe a little bit more concrete terms? Only reference specific resources or set of resources. If you're going to have a wildcard in your policy somewhere, if you're going to say access anything, make sure you limit it somewhere else. For us in Deere, we have certain naming conventions, so we can say everything in John Deere Financial on this team. We can access that set of resources. That's a tighter honeycomb than just the entire thing, but we can still access enough stuff to where it makes our job easier. I had a hard time finding companies that would kind of do this for you. I know within Deere we kind of have our own homegrown solution, but use programmatic checks if you can. If there are certain things developers should not be able to do this, whether it's make a set of access that's too large, too complete, if you will, or maybe it's a certain type of action that you're just not going to allow. Maybe it's like a delete action. You know, if anything is going to be deleted, it has to be done by a super user or something like that. You can use programmatic checks to find those things and to limit on those things. One thing that I think is should be really popular, and I hope kind of becomes more consistent in the world of software, is assuming different roles and using different sets of policies for different jobs that you're doing. If you're developing in a certain website, maybe you can log into a different account or something, like somehow you can use access for that thing that you're working on, and then you can swap over to a different policy, different set of roles, different set of whatever to work on something different, rather than having access to the whole gambit of that all the time. And then, like I said, strike a balance. This is so hard to do well. It's something that I think that all we can do is kind of strive for every day. I think that it revolves around feedback from developers, feedback about what the pain points are in the job, but then also working with security or working with compliance or whatever it might be to ensure that access isn't too broad where it doesn't need to be. Real quick, just a couple of companies I found that did something like this in terms of programmatic control, in terms of handling IAM from a larger organization perspective. Of course, you have companies like Okta that do like a single sign-on that would kind of be associated with this as well. This is more for individual resources in your cloud computing environment. All right, we're almost done, y'all. We made it to the end. A couple of closing thoughts for you just to round things out. Insecure applications are insecure, right? Cloud is not security. You pick something up that's insecure, you lift it and shift it, and drop it into a cloud environment, it's not gonna be secure. So invest in your application security. If you have applications, just make sure you're securing them in some way that isn't just external protections in a cloud environment. Learn to learn. If you are a developer and you want to be an architect, find some certifications, learn from other architects around you, and just be comfortable with the idea that you're not going to know something and you're going to have to explore. You're going to have to take that next step forward in order to really understand how to do something the right way, how to do something securely. Find a configuration policy that works for you. If you have very low tolerance for risk, make everything private, no exceptions unless somebody has a very strong business case, and work from there. Or vice versa, if the stuff you're dealing with is not that important, kind of whatever works for you. And then, like I said before, strike a balance between a minimal set and a necessary set of resources for what your developers need. And finally, cloud is not security. It was coming back to it. All right. Before I go, for any of y'all that are students or have students in your life, any full-time student that is in a 2-year, 4-year, or grad program is welcome to apply for our Cyber Tractor Challenge. This is an event that John Deere puts on. Will now be the 2nd year that we're doing it. We're expanding it to 30 students. Applications are open now. It is a week-long, all-expenses paid trip to a farm we have out in Des Moines, Iowa. You get to hack on tractors. You get to learn about embedded security. And it's just a super awesome opportunity to bring security folks together and to work on something that's really important. So yeah, thank you all so much for coming out today. I appreciate it.